Okay, so how do we choose what goes where? Well, you may have seen this acronym before. ILATE or LIET. Sometimes the L and the I flipped. I'm going to quickly explain what this means. But in general, this is kind of, I don't want to say bogus because it works and you should use it, but it's not, massively, what's the word? Not massively influential in your decision. Usually you can start to get kind of an idea of it. And let me explain what I mean, rather than all this waffle that I'm definitely not going to edit out because I don't have time for that. So, this ILATE acronym is how you choose the U components in your integration by parts. Remember, the part that you choose as U is the one that you're going to want to differentiate. The part that you choose as your dV by dx is the part you want to integrate. So this is how we're going to choose which one to differentiate. So the last example, x cos x, we know we wanted to choose the x as our U because if we differentiate x, we get a 1 and that just gets rid of it. It's not a problem anymore. But what if you've got not something nice like x times cos x, you've got some nonsense with e's and coses and sines and whatever else it may be. That's where this comes in. So the I sometimes isn't seen, but I'm going to include it here just for the completeness, is, I don't know how to write this. I'm not going to write vertically, that'll look horrible. Inverse trig. Just do it like this. Inverse trig. Now, I haven't done anything about inverse trig. If you're only just using integration by parts, you probably also haven't done anything on inverse trig, but I'm going to include it here anyway. The reason, and by inverse trig, by the way, I mean our sine to the minus ones, or our arc sines, depending on how advanced you want to be, how fancy you are, right? The reason this gets chosen first, usually, is because if we have an inverse trig, it is ugly. An arc cos or an arc tan or an arc sine or an arc sinh or whatever it may be, looks ugly. And if you differentiate it, it always just gets left with algebra. The derivative of inverse trig always, well, I don't want to say always because someone will pull out some weird example, but the standard results give us algebra. X's, x squareds, x cubed, not x cubes, square roots, etc., etc., etc. So in general, we want to try and make it look less ugly. If you integrate these things, they don't necessarily look less ugly. But yeah, that one might not be very relevant. L is for logs. Okay. Again, it's because logs are ugly. If you have a ln x, right, and you want to do something with that, well, I don't want to integrate it. Can't integrate it. But if I differentiate it, I'm left with 1 over x, which looks a little bit nicer. Yeah, it's a bit nicer to deal with. Again, the whole purpose of this is we're trying not to have an ugly integral right at the end of our integration by parts. Like that sine x squared over 2, that nonsense earlier. We don't want any of that. We want it to be as nice as possible. The way we sort out a log, we use the ln here, but log or ln, is we differentiate it, we get it into a 1 over x. Sometimes, as I said, you'll see these two switched because it doesn't really matter. If you've got an integral that is a log times an inverse trig, I sincerely apologize. You're probably at uni, go on integralcalculator.com. Yeah, you probably shouldn't be watching this video. Then we get to A. A is algebra, okay? So that would be anything that doesn't fall into a special function category, right? Just an x squared, an x cubed, an x to the 4, etc. Which I'll talk about a little bit more in a second. But that's just your standard x squareds, etc. Nothing fancy, a 2x or a 3x or whatever it might be. There's nothing fancy going on, as in the example earlier. Then these last two, T is for trig, and E is for E, exponential. Yeah? Now, these two, it doesn't matter which way around you do them. You're screwed either way, right? The only reason they're this way round is because late sounds better than late, which is what you'd get if you split the E and the T, right? But either way, you're screwed. The reason you're screwed either way is if you just have a standard trig, which is, a sine, a cos, a tan, etc., and you differentiate it, you're still going to have a trig. Your sine is just going to turn to a cos, and then a sine, and then a cos, and then a sine, and then a cos. It just loops. If you integrate it, it's the same problem. Yeah, you'll have a minus sign, but again, who really cares about a minus sign when you've got, all this trig nonsense going on? Same with an exponential. e to the power of anything, yeah, you're going to get some factors being brought out, right? E to the 3x, that's going to differentiate into 3 to the 3x, or etc., 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 or integrate into 1 over 3 e to the 3x. But that e is still going to be there. No matter what you do with trig and exponentials, they're not going away. In general, these two are usually always, especially at A level, going to be your dv by dx option. Yeah? They are always going to be your dv by dx option. Because it's unlikely you're going to be able to get either of them to differentiate into something that isn't ugly. Okay? Right, there's one more example that I want to cover, and I'm going to keep talking as I'm rubbing out because, like I said, I do not have the time to be editing because, you know, such a busy person. Also, there's a football match on in 7 minutes, but, you know, different problems. The last thing I want to quickly discuss is something I touched on earlier, which is a double integration by parts. And for this, I'm going to use the example of integrating x squared cos x. Okay? So, I know I want a u, a du by dx, a v, and a dv by dx. And I know I'm choosing my u and I'm choosing my dv by dx. Hopefully by this point, you've realized I've got an x squared, which is an algebra, and a cos, which is a trig. Now, you see a trig, you should immediately be thinking that's got to go here. Unless there's, you know, something real special going on. My algebra x squared, that's going to pop up here. Okay, let's fill it out. So du by dx is going to be 2x, and v is going to be minus sine. Now, alarm bells may be ringing with some of you, because unlike the previous example, my x squared is not disappearing. When this was an x, it disappears into a 1, but here, we've still got a 2x. So let's fill out the equation and see what happens. So I've got uv, so that is minus x squared sine x, minus the integral of v, which is minus sine x, I'm just going to bring the minus out, times by du by dx, which is 2x. Well, again, our issue is always this integral. And if we zoom into this, I can actually bring that 2 out, just to make my life a little bit easier. I have got an x times by a sine x. And if we see an x times a sine x, we should immediately be thinking, uh-oh, I need to do integration by parts again. Now, does this mean we're wrong? Does this mean I have to go back to the start, flip them and try it a different way? Well, no, because if my x squared is in here, if I integrate it, it's going to be an x cubed over 3. That's worse. I'm going to have an x cubed in here somewhere. My sine and my cos aren't going to change. They're going to flip-flop no matter what I do. So it's looking like I'm going to have to do it again. Okay. So I'm going to take this integral, 2's on the outside to make things easier. You could have 2 on the inside and do it that way, but just to make things a little bit easier for myself. And yes, I am forgetting plus c's here, but it's not entirely relevant. I get 2 times sine x, x. Once again, I need a u, I need a v, I need a du by dx, and I need a dv by dx. Well, hopefully again we've realized I've got an x, so that can go into my u. My du by dx is going to be 1. My dv by dx is going to be sine. And then my v, again, cos differentiates into negative sine. I say this because it's the way I always remember it. Because sometimes it's difficult to remember where the negative is. So if you remember one of them, I always remember cos differentiates to negative sine. We can always work backwards. If cos differentiates into negative sine, sine integrates into negative cos. Nice way to remember it. And I can put all this together. And obviously I've got a 2 on the outside. So it's going to be 2 times by uv, which is minus x cos x, minus the integral of 1 times by minus cos. So the integral of cos, running out of room here, but hopefully you can now see we've got a nice integral that I can solve. integral of cos is sine. So I've got minus 2x cos x plus 2 sine x, obviously with a plus c at the end as well. So this is my solution to this. So finally, I can pop that whole thing into here, and it's going to look very long and annoying, but I get minus x squared sine x plus 2 times, actually no, I've already done the 2. I've already done the 2. So plus minus 2x cos x plus 2 sine x plus c. And as ugly as it looks, that is our solution. If we had an x cubed, we would have to do this 3 times. Unlikely that would ever come up in a A-level looking paper, but that is how we would solve it. In general, if we have a standard x function to the power of something, every time we do integration by parts, it's going to reduce that power by 1 just from the nature of differentiation.